In this lesson, we are going to take a look at bivariate data. Data where we will have, similar to number 1 here, we will have a year on the x-axis and population, farm population on the y-axis. So to begin, we've already talked about inputting data in a list. So I started by putting in the year, and I coded the year so it would be years since 1900. And it just kind of makes it a little bit easier. The numbers are smaller. Students can put in 1940 to 1985 and it would still give the same exact graph. Then the farm population in millions of people in the L2. So when we're ready to graph a scatter plot, we are still going to hit quit. We are going to stat plot. And in the first stat plot, we're going to turn it on. When we go down to type, this very first one is a scatter plot. And notice it asks for X list and Y list. And we know that the year would be on X, and that's in L1, and Y would be L2, which is the population in millions. And the dots that are going to show up are going to be little boxes. We could pick any of them we wanted to once we get down there. We could pick the little stars, and it would make the dots be stars. And we can hit zoom stat with zoom 9, and we can kind of see this graph. And notice it's not in a perfect line, but it's very close to a line. We don't see any other pattern. So that is how to get our graph there, on the graph and looking at it. And from this, we can tell that the slope is negative. We can talk about the relationship that we see, a negative relationship. It's very close to linear. So our correlation is going to be very close to -1. But let's take a minute and go ahead and get this equation that they've stated in part B. So once we have that, and we're looking for the equation of the linear regression line, we are going to go into stat, calculate, and you can pick either one, 4 or number 8, linear regression, ax plus b or a plus bx. Now, if you go with number 4, it looks like what they've seen in other math classes. So that's what most of us kind of stick with. So our x was in L1, so we're going to pick second, number 1 for L1. L2 is your y. Frequency, leave it alone. Okay, here is something you do not have to do, but it kind of makes it easier when you're doing your linear regression. You can actually have the calculator store the equation in y equal. To do that, you would hit vars, go to y vars, function, and pick number 1. Okay, and another shortcut, if it's a TI-84 upgraded and you've got upgraded the operating system, you can go to alpha F4 and pick number 1. Okay, because that's kind of just a shortcut there for number 1. And hit enter and calculate. And notice it's giving me a slope of -0.558 and a y-intercept of 50.42, which is exactly what the worksheet tells us. So we must have done a great job. And if I go into the y equal, it has put that number in there very precisely. And if I hit the graph, then it is going to graph that linear regression equation. And eventually in further lessons, we're going to talk about the difference between those plotted points and that line and the space between them, known as the residual, and look at those. So here's our best fit line. It's graph. Now, if we want to predict a value, let's say we did not know the year 1952. I can go in and hit second quit and go to vars. Well, let's do the shortcut. Alpha F4, pick Y1, parentheses, I want 1952, and hit enter. And I would predict it to be 21.39 or 21.4 million people lived on a farm. And that is the predicted value. Now, obviously, we don't have the exact value because it's not on the chart, but that is the predicted value. I hope this helps with a little bit of understanding for your linear regression. And in another video, we will talk about how to define slope, y-intercept, and the correlation.